In today's video, we are going to explore how three important plant hormones, auxin, gibberellin, and ethene, can be used in commercial agriculture to deliberately trigger various beneficial changes in plants. Auxin, which is a type of growth hormone, plays a key role because it stimulates plant growth. When auxin is intentionally added to plant cells, it can encourage growth in controlled environments. For example, if we have a group of plant cells in a tissue culture, we can create many clones by using a growth medium enriched with auxin along with the other necessary nutrients. The same principle can be applied to cuttings, which are small portions of a plant, such as the tip of a branch that contains a few leaves. If we place these cuttings directly into soil, they usually do not develop further on their own. However, if we treat them with rooting powder, which contains auxin, the hormone stimulates the formation of roots, and the cutting begins to grow into a new plant. This is an easy and effective method for propagating plants. Auxin can also be used to eliminate unwanted plants, even though it promotes growth. This may sound contradictory, but in high concentrations, auxin disrupts normal growth patterns and ultimately causes the plant to die. This application is particularly helpful because most weeds are broadleaved plants, whereas commercial crops like wheat, barley, and corn are narrow-leaved. That allows us to develop selective weed killers that can be sprayed over entire fields, targeting only the unwanted broadleaved weeds without harming the main crop. Moving on, gibberellin is another vital plant hormone with three major commercial uses. It is used to control seed dormancy and promote germination, to trigger flowering, and to increase fruit size. Normally, a seed will not germinate until specific environmental conditions are met, such as appropriate levels of warmth, oxygen, and water. This waiting phase is known as dormancy. By treating seeds with gibberellin, farmers can override natural dormancy and cause the seeds to germinate even when the usual conditions are not present. This enables multiple harvests per year and allows farmers to coordinate the germination of all seeds at the same time. The same technique applies to flowering. While most plants require specific triggers like light duration or temperature to begin flowering, gibberellin can be used to induce flowering on demand and even boost the number of flowers or make them larger. Additionally, gibberellin helps to produce larger fruits. This is especially important for seedless fruits such as seedless grapes or seedless oranges, which would otherwise be smaller than their seeded counterparts. By applying gibberellin, we can ensure that these seedless varieties still develop into full-sized, commercially viable fruits. Lastly, ethene is a plant hormone that is primarily used to manage the ripening process of fruit. If you have ever noticed that some fruits ripen much faster than others, then you can appreciate how valuable it is to control this stage of development. This is even more critical when you consider that much of the fruit we eat is transported over long distances and may take weeks to reach stores. By harvesting fruit while it is still unripe, we gain time to ship it across the world. Then, once the fruit arrives at its destination, it can be treated with ethene to speed up the ripening process and make it ready for sale. Naturally, most plants already produce ethene as they mature, but during shipping, steps are often taken to block its effects so that the fruit does not ripen prematurely. On a molecular level, ethene works by activating enzymes that accelerate the softening, coloring, and sweetening of the fruit, all of which are signs of ripening. This careful timing ensures freshness when the fruit reaches consumers. That concludes everything for this video. We hope you found the information helpful, and we look forward to seeing you again in the next lesson.